Okay, that's all we have, like the fact table and dim table, right? For the fact tables, we have different facts. So fact means like uh, the measurement for the business process, right? We are including different IDs. For each record, we have different key values and also have like the methods, including like what is the cost, what is the timing services. And for the methods, remember they have two special things. One is they're numeric, and also they need to be addictive, which means it could be do some calculation for to the sum, the cost, or the time. So now the next steps we need to build the cardinalities between them, or like connect the dimension table to the fact table via the primary key and foreign key. So we need to use this one. I'll make it bigger. We call it like monetary to money, one to money. They actually has two parts. So for this part, as you can see, like there is like a feet, right? So we can see this one to several different feet, right? This is one to money. This one represents the relationship between like the dimension table and the fact table, which is one to many. Like for example, if I want to build the connection between these primary keys, the mechanical IDs connect with the fact tables. This part means one mechanic ID is associated with at least one service in the fact table. So that is what that means. And going back to the left side, this one, did you see like two slots here? They are one by one, which means like one service in the fact tables, like one record, is only associated with only one mechanic ID, like one mechanic in the in this dimension table. So that's the relationship between this dimension table and the fact table. And same things, we can build more. You can drag it here, or you can just copy and paste. They all works. For this one, same thing. And we, for each time specific to the date, right, is associated with at least one record in the fact table. Diagnosis, which means like the specific diagnosis here is associated with multiple different services in the fact table, right? Similar, let's make more. And the specific ID, like vehicle ID, is associated with at least one of the service in the fact tables. Fact tables have a different record of different services, right? So one vehicle, one kind of vehicles is associated with at least one. Could be multiple, at least one in the service. And same, and this one, I'll say at least one kind of services and associate with at least one service in the fact tables. And it could be one to many, like one services, specific code, specific service might have us in different record of service being made, right? Like for example, you want to change the oil, like the changing oil could have a specific code and specific description, right? But in the fact tables, which means like people coming to the store and to change the oil, a lot of different people and different cars are gonna change the oil, right? It have at least one. It could be multiple. So that is why the relation between this one is one to many. Okay, and then I think that's all set. So the next step, I want you to take a snap and paste it in the Word file. Then you will be all set for these questions. Let's go back to our lab. So the next one, we still need to construct a star schema. And these times, we still use the same tool to draw it carefully. So the data mart want to set up a tracker the method of sales, right? I don't want to highlight this part. So it could be like the sales, I'll highlight it here. And also items, different items, and different salesperson. They all could be dimension, right? And also customers. That's a lot. And to track their sales, they need to maintain information on the product being sold. So that is why the products has to be the dimension, right? But the product's item is same, right? Since I highlight the product, I don't need to use this item anymore. And the sales, okay, they write it clearly. So products, salesperson, customer, and also we have, let me highlight their attribute, right? For each specific dimension model, we also have the attribute to explain like each different dimension. So I don't need to highlight this part anymore. Just like get rid of them and highlight here, salesperson, and the products, and the products customer. And then location. Great, I like it. I like these questions. It's quite easier. Date. And also, okay, so for they are the dimensions. And in the middle, it should be the sales. It could be the fact table, right? I'll name it yellow. Okay. Each product attributes, including its description and the categories. So they are the attribute that we can put in each dimensions. So the location include name, population, average count. Customer names include different names, address. This is for customer and also for each other dimensions, including to appropriate attribute. And also, we need to identify their primary key, foreign key, that's common, and data type. Data type means like it depends on what data you have. Some such as if it's cost or sales, we might just using the money as a data type, right? And if it's location or name, we use VACA or car 2, VACA 25, or VACA 50. And if it's binary variable, like what we did in assignment, it could be like BIT, and integer. ID should have to be the integer, right? So you need to also specify each data type for this lab. Okay, let's do it. So when you are here, you can save this one by click save or save as. Also, we need to create a new one. So we click file, click a new blank diagram. So I'll name it sales because I have one already. So I just name it a different one. Doesn't matter. It won't affect anything. So now let's start to do it. How many tables we need to build? So it seems like we have 1, 2, 3, 4, 5 dimensions tables, right? And also we have a fact table, which is a sales in the middle, like the fact sales. So you need to, remember what you need to do is click entity relation, and we want to use this one. This one could be one of the dimensions, and also we need the other several different ones, including 5 dimensions. They are the customers, products, salesperson, and what else? Let's see, and products and location. And oh, it's right here. So we need to edit these tables and including different attribute. So the first one, maybe I'll say, let's do the products. So right, the products should be depends on different description and the category, right? So we might have description and the category. We also need to have the key value, which is the product ID, right? And the salesperson, also we need has like in their names and maybe their ID, right? At least 2, so we can use their name, ID, or if you want, you can use their phone number. And this one is a location including name, population, and average count, customer name, address. So the attribute in each dimension table. In the same times, we need to have like different key values like date ID, customer ID, salesperson ID, location ID, and product ID. So just keep typing them in your table. Since I don't want to spend too much time on this part, so I already make mine, and you can just easily follow with what I did. You can stop the video here. And moreover, did you notice like I add the data type associated with each different values, like product ID. The ID they all has to be integer. So I put int. It's required by the questions. Make sure you have the data type in your plot as well. And description, it has to be VACA 25, category 25. And for some like sales, it has to be money, right? You can capital the money if you want. And at the day could be like daytime. They all works. Then once you build all these tables and you connect them with like one-to-many cardinality and connect with their primary key to the foreign key, then you're all set for the table. So we are done.